Okay guys, so to graph a piecewise function, I know this one looks really intimidating because it's got 5 different functions inside of it, is to follow a few simple steps. For one, what I like to do is I like to make either a mental list or literally write down a list of all the functions that you see, all the details about them. How have they been transformed compared to the parent function? What table of values do they require? So that's how I usually start a piecewise function. Just ask myself, what type of functions are there? What are their transformations, reflections, and shifts? And what table of values am I going to need to use? The second thing that I do is ask myself, how is that function restricted? All of these functions have restrictions, and those you can see by the domains. Okay? So what I like to do is I like to pay attention to where those restrictions occur. You can see that some functions are restricted at -6. Some are, like this next one is -6 and -2, -2, +2, +2, 5, and 5. So take a look at all those different restrictions, those values on the x-axis. That's the second thing I like to do. I do all of that before I put my pencil on the graph itself. After I list all of those important details and identify them, that's when I finally start graphing. I also recommend that you use different colors when possible. So I am going to go ahead and start by doing what I suggest to always do first. Just label the types of functions that you see. I've got a cubic. For this specific cubic, I'm going to think back to the table of values that is appropriate for cubics. An appropriate table of values for cubics is to use the x values from -2 to 2. Now if I cube all those values, -2 cubed is -8, -1 cubed is -1, 0 cubed is 0, and 1 cubed is 1, 2 cubed is 8. So that's the table of values used for cubics. Then I ask myself, how was this function transformed? So this function got shifted left 7 and up 3. So my new origin is going to be -7, 3. That's also an important thing to remember. Which way was it transformed, and where will your new origin be? The next thing that I notice is there's a negative in front of the grouping symbol. That means that this is a reflection over the x-axis. Reflection over the x-axis. Reflection over the x-axis means that your y values change signs. So I'm going to go ahead and change the signs of all the y values because of the x-axis reflection. Okay, so that's that for the cubic. Next, I'm going to look at the next function. It's quadratic. This one was shifted left 4 and down 2. So my new origin is going to be -4, -2. There is no reflection. So as I start to think back to my table of values for quadratic functions, I don't need to worry about changing the signs for anything. Now the table of values that's appropriate for quadratic functions is using -2 to +2 on the x-axis, and then I square those. I raise them to the second power because that's how you find, that's how the quadratic function works. You take your x value and you square it. Remember, I don't have to change any of the signs because there was no reflection. The next one is a linear function. With linear functions, you're just going to use the slope and the y-intercept to graph the line. You do not need a table of values. The next function is absolute value. Now this absolute value was shifted right 3 and down 1. So my new origin is at 3, 1. It is reflected over the x-axis, which means I'm going to have to change the signs of my y values. So for absolute value functions, it was appropriate to use the table of values from -2 to +2 for your x's. Remember, when you take the absolute value of a number, it becomes positive. So this was the original table of values that corresponded. But we are going to have to change the signs, change the y value, and actually I should have been more specific here. Change signs of the y values because of the reflection over the x-axis. So I'm going to go ahead and change all those. You can't change the sign for 0. And then last but not least, we've got a constant function. When it comes to constant functions, those are horizontal lines that intersect the y-axis at that value, at -1 in this case. Notice how much work I've already done and I haven't even started graphing yet. The next thing I do is I ask myself, okay, this cubic, for example, the first function, I am only allowed to graph it to the left of -6. So I go through and I ask myself, what do these domain values actually mean? X is less than 6 means that I want all the ordered pairs that are to the left of -6 on the x-axis. So left to the left of -6. Because it's less than and not less than or equal to, this is going to be an open point. The quadratic function is limited between -6 and -2. So we're going to be graphing the quadratic between, oops, I spelled between wrong. Between -6 and -2. The -6 is going to be open, but the -2 is going to be closed. How come? We'll look at the restriction. They used a symbol without the or equal to for the -6, but for the -2, they used the or equal to, so that one's closed. And you go through the rest of the functions and ask yourself, what am I going to graph? Where am I going to graph that, and between which numbers? So this one, this linear is between -2 and 2, both open because they didn't have the or equal to sign in the symbols. This one is between 2 and 5. These are both closed. So if you plot a point that lands on those values, you're going to make sure that they're closed. And then this one, it says x is greater than 5. Notice that your right hand makes the greater than symbol, so this is going to be anywhere to the right of, all ordered pairs to the right of 5 that belong to that constant function. Okay, so what I'm going to do now is I'm going to take a highlighter and I'm going to draw vertical lines on the x-axis that pass through those cutoff points. So one of the cutoff points is -6. So I'm going to draw a line that passes through the x-axis at -6. Another point or value for x where there's a cutoff is at -2. There's a cutoff at 2. So I'm getting all of these values. So all of these values that I'm mentioning, -6, -2, and +2, all come from the domains. So every number that they list in the domains, doesn't matter which function it's in, that's where you're going to draw your vertical lines. And then 5. Now I'm finally going to go ahead and start graphing these functions. So the cubic function has a new origin at -7, 3, 2, 4, 6, -7, 3. Once I plot my initial point, so this is my 0, 0, my new origin, I'm going to go ahead and follow the table of values that I had previously. So I'm going to go left 2, up 8. Unfortunately, there's not enough room in my graph for that, so I'm not going to plot that point. Then I'm going to go left 1, up 1. Then, so this is my origin, 0, 0. Then I'm going to go right 1, down 1. But do you see how that lands on one of the cutoff points? So I have to go, whenever you're about to plot a point that lands on one of the dashed lines, the cutoff points, ask yourself, do I plot that point as a closed point or an open point? We had already decided that it was going to be open because of what the domain stated. Now remember, this is a cubic. Cubics look like this, and they technically continue on, but they only want me to graph the cubic to the left of -6, so we don't want to keep graphing the rest of the ordered pairs from the pattern. Okay, next I have my quadratic. It was shifted left 4 and down 2, so that's my new origin, and so that's my new 0, 0. So now I'm going to go ahead and use the table of values for the quadratic. I'm going to go left 2, up 4. But remember, if it lands on a dashed line, you got to go back to your domain and ask yourself, was it supposed to be open or closed? For the quadratic, they wanted open if it landed on the -6. I'm going to keep going on with the pattern, -1, 1 from my new origin, -1, 1. Remember, 0, 0 is your new origin of -4, -2. Then I'm going to go 1, 1, so right 1, up 1. And then for this last one, 2, 4, I'm going to go right 2, up 4. But again, if it lands on one of the dashed lines, look at your domain. We had already decided that at -2 it'd be closed. So your parabola is going to be between those values with an open point at -6 and a closed point at -2. For the linear function, I need ordered pairs between -2 and 2. But when you're graphing lines, you always start on the y-axis with the y-intercept. So the y-intercept is 1. The slope is down 1 over 2. Remember we had said that if it lands on -2 or 2 on the x-axis, those x values, -2 and 2, it has to be open. So I'm going to go ahead and put open here. I also need the part of the line that's to the left of 0 because they said from -2 to +2. So I'm just going to go ahead and follow the slope of, instead of going down 1 over 2, I'm going to go up 1 over 2, and I'm going to just draw in green kind of like over that closed point because I want it to be obvious that it's open for the green function, which is linear. So again, the y-intercept was 1, the slope was down 1 over 2. I went backwards, up 1 over 2, so I could plot a point. Remember, they wanted the linear function to be between -2 and +2. The quadratic had to be between -6 and -2. The cubic had to be to the left of -6. So now I'm on the absolute value function. The absolute value function has a new origin of 3, 1. It opens down because it was reflected over the x-axis. That's why we changed the y values. So I'm going to follow the pattern of left 2, down 2. But guys, that's not going to be between 2 and 5. So that left 2, down 2, I don't want to plot that point because that's not within the range. Okay? Within the domain that they want. So I want to see that V shape only between the 2 and the 5. So if you're about to plot a point that's not within that domain, then don't put it. So I'm not going to be able to plot this first ordered pair of left 2, down 2. Left 1, down 1, I can. Now, let's see. On the absolute value, it's closed at 2. So I'm going to go ahead and fill it in. Notice that it was open for the green but closed for the orange, which is my absolute value. And then I'm going to keep following the pattern. So I was able to go left 1, down 1. Here's my origin, which is 3, 1. Then go right 1, down 1. right 2 down 2. If it lands on the 5, remember we had already decided that it was going to be closed because it had the or equal to in the domain. And stop there. Finally, the constant function says f of x or k of x equals -1. That is a horizontal line that goes through the y-axis at -1, okay? But I don't want it to exist through all of those points. They only, they only want it to the right of 5 on the x-axis. So open point at 5 because it said it has to be greater than 5, not greater than or equal to. And then forever to the right. So that's what to the right of 5 means. Okay, hope this helped. It does take some time. I promise the ones on your homework are always going to be easier. If you have any other questions, feel free to contact me through Remind. Good luck, guys.